Hi, I am Ratnavira TT, and I will now present the two vulnerabilities I worked on and explain how we fix them. First, the use of externally controlled format string, which is section 3.5 of the report. If you look at here the old code snip, you can see the middleware is login request.path and request.method directly. Uh, without any checks. The problem with this is that both values come straight from user input. An attacker could craft the malicious path containing special format characters like percentage or line breaks. This could inject harmful data into our application logs, leading to log poisoning, sensitive data leaks, or even unexpected code execution in creation cases. Uh, Now, if you look at the fixed code, you will see that we introduce a function called sanitize log input. This removes dangerous characters such as percentage, new line, tab, categories returned before login. Then instead of login row input, we log only sanitize version. Uh, so the key difference is before unsafe user input was logged directly after inputs are cleaned first, ensuring safe and reliable logs. That prevents attacks from manipulating our log files. Next, look at imposter type validation section in 3.6 of the report. If you look at the old code here, the application process certain directly from the request body. There are no checks on whether this data is really an array or whether its properties have the correct types. This means an attacker could send malformed or malicious input, for example, a string instead of a number or object with missing properties. This could cause the application to crash or even allow them to bypass key business logic. Uh, now, now compare that what with the fixed code here. Fixed code here. Uh, we first check that certain is actually an array. Then we validate every item inside an array to make sure it has required properties. Name, image, desk, ID, price, and card quantity. On top of that, we also strict type checking. Name, image, and ID must all be string. And while price and car quantity must be numbers. If analyzing is invalid, the server returns 404 error and reject the request. The difference is here clear about the app trusted user input blindly after we enforce strict validation and only allow property structured data. This stops attackers from caching the app or exploiting weak spots in our checkout logic. So overall, these two fixes cover two critical areas: login and input handling. By sanitizing our logs and validating our inputs, we reduce the risk of attacks, made our code base more robust and improved the overall security of the application. Thank you.
Hello, I'm Krishmi. I did 22, 35, 20, and 26. So in our system, I found two vulnerabilities. First one, information exposure and open redirect. Uh, in here, you can see in SLIIT, it fact a vulnerability in the order route, where error objects were returned directly to the client. And it also highlighted the expowered by header as an information exposure risk, and also detected that in the pay button component, the application was assigning response data URL directly to the window location href, which creates an open redirect vulnerability. So here the code sends the entire error object back to the client. So this means stack traces or database error could be leaked. Uh, here the here the open redirect vulnerability. So here the client trusted whatever URL comes from the server, which means user can be redirected to the attack controlled website. So in fixed version, in here you can see information exposure. uh, I return a safe generic message to the client and lock the full error only on the server. So this prevents sensitive details from leaking. And I also disabled the X-powered by header using Express and Helmet to uh, prevent framework disclosure. And an open redirect, uh, this is a fixed code. So uh, in here, in the fixed code for open redirect, so I added validation. Redirects are only allowed if the URL belongs to the same origin or a trusted wish list. So malicious URLs are blocked and locked. Thank you.
Hello, I am HMTW here. I will present my part. First, I fix cause misconfiguration. Originally, the server allowed a request from any origin using a wildcard star. As you can see here, uh, this is risky because it lets unauthorized domains access our APIs, which can expose sensitive data. To fix this, I replaced the wildcard with the strict allows list of trusted domains. Now only approved domains can access the server. Uh, as you can see, untrusted requests are blocked with the course policy. Uh, and, trusted request works correctly. Uh, this ensures stronger protection against CSRF, and data thief. My second contribution was adding a author with Google Open ID Connect instead of rely on local username and password. Users can now log in with their Google account. As you can see, the login flow redirect users to Google after successfully login. The app receives tokens, verifies them, and retrieves profile details like email and name. Returning users are logged in uh, while new users are guided to complete their profile. Uh, as you can see, new user have to complete their profile. This implementation reduces password risk, prevents CSRF and replay attacks using state and nuns, and align with the OWASP standards.
Hello, in this video, I demonstrate how I fix two security vulnerabilities, which are cross-site scripting and hard-coded secret. Here, SNCC identify cross-site scripting vulnerability in the post root of order.js, where user input could potentially inject script into the database. And this is the proof that SNCC identified hard-coded secret, which is in Firebase configuration .js file. So this is the vulnerable code. Notice that we directly use request body to create a new order without sanitizing user input. This is the fixed code. I sanitized the order description field with sanitized HTML, as you can see in this screen. This ensures any malicious scripts are removed before saving to the database. So this slide, you can see that I fix, as you can see in here, after applying the fix, the malicious script is no longer executed. The input is sanitized, as you can see here. Now, the second one I fixed is the hard-coded Firebase API key. Hard coding Firebase API key is risky because anyone can access the repo, can see them. So I moved the secrets key into a .env.local file and to the gifting node to prevent exposing them in the repository. This is the previous code, the one level code. This is the fixed code of the Firebase. That's all from my part. Thank you.